through and gets trapped. Well, we had two other rays. So that ray that used to bounce off, so this ray that was bouncing off, because there's a hole in the atmosphere, it now has an opportunity to come through and increase our heat. So instead of bouncing off, it's going to come in and it's going to get trapped too. So these little squiggles here that are representing our heat, it's increasing now because that second ray can now get through the atmosphere and heat up our Earth, okay? And then that last ray that we had in our first one that was absorbed by the atmosphere, it's gonna have an opportunity to come inside as well, and it's going to get trapped and increase our heat some more. So if you did this in a color, like in a red, then you could really see, but you see the difference from your first one to what we have right now. The amount of heat that we had in the first one versus what we have right here. So now all these rays are having an opportunity to come through our atmosphere and heat us up and increase our average temperature.
So another way to explain it is that so we're to reference classrooms, but if we were in a classroom and someone threw a bunch of tennis balls into the doorway, all those balls would not go right back out the door, right? They would bounce around inside of the classroom. So if you think of like the heat from the sun as those tennis balls, that's why the Earth is getting more and more warmed up, is because there's constantly a bunch of tennis balls being thrown into the classroom, and only a few are leaving right back out, but all of them are just kind of staying in there and creating all this heat. So the reason the sun rays don't bounce right back out is because there's the ozone layer that's still protecting it, but also because the shape of the Earth, it doesn't allow, it's not flat like this where it just goes bop, bop and bounces off. We know that rays bounce off diagonally. The infrared rays bounce off diagonally. So that's global warming. You guys are probably still writing some things, and this is on record, so we'll see if it can be uploaded to somewhere on the internet for you guys later. Remember, if there's any questions, you guys can type into the group chat, the Zoom group chat, and I'll try to answer them while Ms. Bannerman does her drawings.
Let's add a little sentence down there so you guys have a little note if you can't remember everything that we said while we're drawing.
I'm putting the notes into the chat as well. Mm-hmm. So both places.
Can you make it bigger?
Let me see.
What you can do is click on Ms. Bannerman. If you have all of the screens up of everyone's faces, you won't be able to see it, but if you just click on Ms. Bannerman, then it should be pretty big. Yes, Joshua. Yes, Joshua, you should be drawing what global warming looks like based on the picture Ms. Bannerman has on the screen.
Keithan, did you get it bigger?
Kaori, that's a great question. We're going to answer that in another square, okay? I'm trying to figure out who 502 is.
Yes, it's bigger.
You guys all set? You ready to move on? Okay, so in this bottom square, if you will do a little something special, divide it in half this way, horizontally, and then do a vertical divide as well. So you have 3 little squares in that one.
The bottom.
Uh-huh. And we're going to talk about those greenhouse gases. And where they come from. And then we're going to talk about something called CFCs, which stands for chlorofluorocarbons.
Yes, we will take a pic. We will try to post pictures of it, but I want you guys to have this to show that you're actually following along, and you're going to take a picture of your best effort, and then you can fill in the details later, okay? Okay, KK.
So let's see if we can get some of you guys to participate in your chat over there, okay? So do you know some greenhouse gases? These are the gases that are in our atmosphere that get trapped and help us warm up the atmosphere. So if you know some, will you post them in the chat?
And it was a hint. I mean, a hint is it was in the video that was sent out, at least to my kids yesterday, about global warming or climate change. Okay. So what are some greenhouse gases that were from the video? Type it in the chat. Methane, excellent.
Yeah. Awesome,
And
Sean. So let's talk about methane. Okay, so methane is CH4. Do we know where methane comes from? Like, how does it get into our atmosphere? This is the fun one. So CH4 is methane.
Go ahead and type in where methane comes from. I know some people know that, especially boys.
Mm-hmm.
The question is, where does methane come from? Or where do you find methane?
And
Type it in the chat for whoever hollered out something.
yes, that is correct. Methane comes from what we call flatulation is the official term for it, but in simple, it comes from farts, right? So
I know some of you guys know.
Yes, because we know in our classroom. So you have a lot of farm animals, and as they pass gas, they release methane, and you too. Okay, so I'm gonna write farts on here. You can write flatulation. We're conserving space, okay? We'll say flatulation. Okay. Do we know where else methane comes from? have you ever seen Scooby-Doo and they're walking through the swamp and the swamp is bubbling up? Okay. What causes those bubbles is that methane under the surface. Okay. And it comes up and it gets released. So swamps.
Yes, Joshua, wetlands. And I'm going to add in
Mm-hmm.
decomposition. Anywhere where there is things that are dead, there's a certain smell. That smell is release of, some of the smell is methane as well. So with decomposition,
Mm-hmm.
all those bacteria in there breaking things down, methane is also released. One thing I want you guys to know about methane is that it is one of the hottest greenhouse gases. It is very, very, very hot. And some of you guys who pass gas understand that. But it's hot and it it traps the Earth's heat as well. So that's why we call it a greenhouse gas, because it's so warm and it helps keep the Earth warm. Is marsh gas the same thing? Yes, the gases that come from marshes is the same gas. I mean, it's not the same exact gas because we have different bacteria, but it's bacteria that's actually creating this methane. And it happens in our stomachs and in cow stomachs, but it also can happen in the dirt or in the water. Great question.
Okay. And then I'm also going to add melting ice caps, because we know that with global warming, it's melting the ice that's on our Earth. And a lot of our ice is at the North Pole and at the South Pole, so like the Arctic and Antarctica. And trapped in that ice are gases. And so as the ice is melting, those gases are being released as well. And part of that is methane.
Okay, Ori has to go to
Should I add fracking?
Okay. I'll just say yes. Fracking, probably not yet.
Okay. Okay, do we know any more greenhouse gases? What do you guys breathe out?
I know my students had to reply to a Flipgrid that had all the greenhouse gases. And so unless you don't remember from, there we go. All right, let's see. Very good. Carbon dioxide is what we breathe out. Oh, so cute. So where does that come from?
We gave you one.
Oh, oxygen. Let's stick with the carbon dioxide for now. So carbon dioxide comes, we breathe it out, right? Is there any other place that carbon dioxide is coming from, is the question.
Think about your cycles drawings, y'all, because we drew all those cycles on that one environment drawing. So when we talked about the carbon cycle, that CO2 was coming from some certain places.
Decomposing plants, very good. Yep. Plants are made of carbon dioxide. We are made of carbon. So whenever we die and we decompose, whenever anything living dies and decomposes, there's a certain amount of carbon dioxide that's being released. Very good.
Mm-hmm. And then when you guys drew your vehicles, that is also another way that we release carbon dioxide into the atmosphere, is through burning of fossil fuels. Okay. So here's where the greenhouse gases get a little bit more complicated, right? So let's talk about nitrogen dioxide, which you might not be super familiar with, but It's going to come from some places that you're probably familiar with. Combustion, when we burn fuels in our cars, that's going to release nitrogen dioxide. So that's a little bit of fossil fuels there too. And also when you see volcanoes erupting, a lot of the gas and waste that comes out of that volcano as it's erupting is releasing nitrogen dioxide as well.
And Joshua did say nitrous oxide is a greenhouse gas.
Awesome. And then the last one is super simple, y'all, is water vapor. Where are we getting water vapor from?
I know one of the videos talked a lot about water vapor. Maybe what is water vapor? That might be a question too, because evaporation, very good. It's coming from the water cycle. Mm-hmm. Good job, Katie. Why y'all messaging me privately?
What are they saying? Thanks, Anthony.
They're answering the questions, yes.
Don't be scared to put it in the big group chat. There's no judgment. There's no judgment.
So Anthony, very good, evaporation. And so the sun, right? The sun is hitting the water and the water is evaporating, and then that's creating more heat. So remember, greenhouse gases are all about, those are the gases that are trapping heat, the Earth's heat that comes from the sun. So water vapor, when it's floating around, and that's why when it's humid outside, it's not cold. It's actually quite warm because there's a lot of water vapor just kind of floating around. And so, yes, you're right, through the water cycle. So we had CO2. Let me look at yours, Bannerman.
Mm-hmm.
There it is. Uh-huh. So can we talk about why all these things are happening naturally, right? Methane, that's a natural thing. CO2 is natural. Nitrogen dioxide is natural when it's only coming from a volcano. And then water vapor is from the water cycle. So these are things that are supposed to happen on Earth. So now we need to talk about the things that are throwing off this natural occurrence, the natural phenomena, the greenhouse effect using greenhouse gases. Is there a way, or how do we as humans speed up any of these four? Besides car combustion, we already talked about that in fossil fuels, but like, how are humans adding to methane being produced on Earth? And we can't say FARS as an answer. So what's the question? How are humans adding to methane being released? Think about what's releasing methane that humans are adding to. Put the question in the chat. So fossil fuels, would fossil fuels be an answer for releasing methane? So Joshua, we'll say that fossil fuel are in charge of releasing CO2 and also some nitrogen dioxide, but not methane. So if we're unsure, or we don't know yet, that's fine. So basically methane comes from living things. So the thing, when we eat meat, and I know you guys think I'm like a vegetarian, I'm not. When we eat meat, we are adding to methane being created on Earth. Why? Why is meat adding to methane being released? Aiden, you have a question? You can type it into the chat if you have a question or a comment. So cows, if you eat beef, cows are going to be adding to methane because of the way that their bodies process, what is it, hay they eat, grass? So cows are a huge producer of methane. And the only reason why it's a problem is because we eat so much of it. Growing up in California, there's an actual town, it's a ranch that you drive through, and it's maybe 15 minutes of driving and you just smell methane the whole time. It's because all those cows are releasing, so there's tons and tons of cows and they're releasing just methane. So that is a big deal. I know we don't think of it as that big of a deal because maybe we don't see a lot of ranches in Georgia, but the places where they do produce a lot of beef, there's tons and tons of methane being created there. Does that make sense? So once again, less meat you eat, you can save the earth.
Mm-hmm. That's why they say meatless Mondays. So if you just reduce like one day of eating meat, then it can help with the release of some of these greenhouse gases.
And what was it that I said about methane that was different than the rest of them? Do you remember what I said about methane as far as it being a greenhouse gas? It is very hot. That's right, Katie. Out of that list, it is the hottest. Yes, Kelsey. So methane is the hottest greenhouse gas. And methane is a result of eating so much meat. So that's why they say have meatless Mondays or be a vegetarian, not just because you want to save the poor animals, but there really is a good benefit to help saving the earth through not eating meat. So that's kind of a thing that we worry about. Another fact before we move on is they look at CO2 as far as being the measurement for the earth getting hotter and hotter and hotter and hotter. But the reason is because CO2 is released really readily. Yeah, hold on. CO2 is being released really readily, but because CO2 is heating the earth, then it's adding more decomposition and then more methane's being released. So CO2 is not as hot as methane, but CO2 can lead to more methane being released because of the decomposition and the ice caps melting, and there's all kind of methane up under the ice. So it's a problem because we don't want methane to get out into the atmosphere. CO2 could lead to that. Does that clear some things up? And I'm gonna, Ms. Bannerman, if you could talk, I'm gonna be quiet so they could see. I think they have it on speaker view. They want to see the chart.
Okay. Okay. So I just added that methane was the hottest. So you have that as a note there. And then we're going to talk about chlorofluorocarbons, so CFCs. So the greenhouse gases are things that are occurring naturally. So now we need to look at what have we done as humans to contribute to these gases that are building up in our atmosphere and causing our Earth to be much warmer than it is now or has been. So CFCs stands for chlorofluorocarbon, and these are really highly stable molecules that we created. They were man-made. Okay, so they're highly stable. And CFCs are man-made. Pardon my handwriting on this side because I'm trying to write around my little setup here. Okay, so they're man-made, and we find them in things like refrigerants. So the chemicals that we run through our air conditioners and our refrigerators that help keep them cool have CFCs in them. And the good thing about it was we made them so they highly stable. That means they stay around for a long time. They don't break down really easily. So in refrigerants, also in what we call propellants, and that's anything that is like an aerosol. So like in a spray can. So when you think about like back in the day, hairspray comes in that big, tall aerosol can, and it had a lot of CFCs in them. And then also in plastics. So think about how long plastics stay around. They don't break down really quickly because they had a whole bunch of CFCs in them. So what's the problem with CFCs? They're good because they stayed around for a very long time. But the bad part about them were that when you look at your global warming square and you see that big hole in the ozone layer, that was caused by CFCs. So Ned, I'm going to write this formula for them.
Mm-hmm.
And then we'll talk about that. So
if you think about CFCs, while she writes it, and she'll talk when she's done with that. But if you think about CFCs being highly stable, what they were able to do that other molecules couldn't is travel into the upper atmosphere. And when they get all the way up there, that's when they're wreaking havoc. So we're going to put the formula for how CFCs are breaking down the ozone layer, which I know you guys have heard about the hole in the ozone layer, but we're actually going to show chemically what's happening up there. Now, ozone is not something that you can see. The ozone layer is not a blanket. It's not a physical thing. It's a collection of O3 molecules. So the oxygen we breathe out is O2, and the O3 is just kind of a higher powered version of oxygen that we cannot breathe. So, but it's still a molecule, and it's still it moves and breaks down. It's not like an actual glass ceiling or anything like that. So I think she's done. So Ms. Bannerman, if you want to explain the.
Mm-hmm. So those CFCs, when they are coming into contact with the ozone, basically the simplest way I can say it is like they're eating the ozone. Okay. So those CFCs are breaking down that O3 and turning it into a different molecule, which is hypochlorite, which is the ClO negative, and O2. So they're breaking down those ozone layers, right? So one molecule is breaking down 1 million ozones. And because those CFCs stay around for so long, they're still in the atmosphere just eating ozone. So like our grandmothers, back in the day, who used all this aerosols, right? And all these refrigerants and plastics and things that had the CFCs in them, because they're so stable, they're staying around for 50, 60 years. And the length of time that they're staying around they're still eating up the ozone. So they eat up all the ozone, and then they put this big hole into the atmosphere. And now we have this big gap in our atmosphere that's allowing all of these rays from the sun to come in.
I'm going to type a question in the chat. Uh-oh. Oh, wait.
It's there.
Okay. So the question is, globally, why is ozone depletion still a problem? And that's for you guys to answer in the chat. Why is it? First of all, CFCs are banned in the United States. Once they discovered that this was the problem that was happening, there was actually a machine that went up to detect how many points per billion or parts per billion of CFCs or of ozone are in the atmosphere, and they realized there was no more, but we can't, they've been banned in the United States. So my question is, globally, why is ozone depletion still an issue if CFCs are banned? Let's see who's got it first. Kelsey, okay, so illegal use or practices. Absolutely. So, and that's not, I'm not going to address the global part yet, but if someone was to keep a refrigerator for a really, really long time, if your grandmother still has her deep freezer down in the basement, that could be maybe not even illegal, but you know, it's still giving off CFCs. Old vending machines maybe could be giving them off as well. Maybe that, I mean, my grandmother used to keep hairspray and all that kind of stuff too. She probably has stuff with CFCs in it as well. She's 90 something. So that's true. But what about globally? Can we stretch our minds to think about other countries? Absolutely.
Mm-hmm.
Yep. So when you have an unstable or poor, Kelsey said, if you have an unstable or poor economy, third world countries, they didn't advance. What if the country didn't even exist when they banned CFCs? And then they're developing and they're like, this is this great thing, and let me, you know, help with my economy in this way. Well, they missed the whole CFCs are bad, right? And yeah, they weren't present at the Montreal Protocol, Ms. Bannerman.
Yes, I'm writing.
There's some countries that were there, but there's some that were not. So I think that it's important to understand that globally, there's countries that are still using, remember DDT, we talked about that, but they also are still using CFCs because they're jumping on a little late when it comes to this environmental thing. And their country having a better economy is probably trumping them, you know, causing havoc on the earth. Could be.
And so, guys, in 1986, the Montreal Protocol was established and it banned CFC use. So that's great for the people who were a part of it. But like Ms. Ned just said, if they weren't a part of it, or they weren't established when that protocol was put into place, then they still could be using CFCs, which are still going out into our atmosphere and eating our ozone layer. So the hole in the ozone layer that you drew in global warming is about the size of the United States. Okay, so just think about how big that is. So there's a hole that big in our atmosphere that's letting all of these dangerous rays through.
So does everyone have this chart? Let's see a thumbs up if you're ready to move on, have a clear idea about what we're talking about, because we want to make sure that we move through this stuff, but we want to have time for questions in the end or some extra. Okay, Keithan's got it. Good. Good.
Awesome. Okay, so last box. If you'll title it UV rays. We're doing this chat and this Ned having class. Thank you guys for joining. We really do appreciate y'all logging in.
You're awesome.
Okay, so UV rays. There's 3 types of UV rays. This one's easy. UVA, UVB, and UVC. Where have you seen these rays before? It's almost summertime. When you go shopping in the Walmart for summer prep things, where have you seen these 3 types of rays before? On what product?
That's right, Brooke. Sunblock. Why are you guys privately sending me messages? I don't understand. And Katie, I'm gonna have a bone to pick with you, Katie, after this. Talk about the rainbow. No.
No.
Sunblock. Yes, Evelyn.
Yes.
Good
Yes.
job.
So when you guys see on the side of sunblock where it says broad spectrum, like your sunblock should protect you against UVA, UVB, and UVC rays. So what happens when you go out in the sun is that the UVA rays that hit your skin, they cause aging and wrinkles. Okay. So you know that people who work in the sun a lot, if they don't use sunscreen, as they get older, their skin starts to look older and it gets wrinkles and things like that. UVB rays cause burning. So when the UVB rays hit your skin, those are the things that cause sunburn if you're not wearing sunscreen. Okay. And the UVC rays are the ones that can cause cancer. Okay. So we've all seen, you know, I always tell this to my kids in class when we're talking about it, like you've all been to, or if you've been to any beach around, you know, the people who spend a lot of time in the sun because their skin starts to kind of look like leather, right? Because those rays for years and years of being in the sun have caused their skin to age and wrinkle and to burn and things like that. So when you're wearing sunscreen, which everybody should be doing, even if you are brown or have melanin in your skin or not, you still should be wearing sunscreen to protect your skin from those rays. If you buy sunglasses, sometimes you'll see sunglasses that say polarized on them, and those are sunglasses that will protect your eyes from those different rays.
So we do have, if you think about it, for those of you who just want to talk a little bit further about the difference between these rays, it's the size of the rays. And so UVA has a larger spectrum, like it's a little bigger. B is a medium, and C is a small one, like a serrated knife. So if you think about cancer, the cells that we have are very, very small, and they're affected by those micro, kind of like microwaves. It's not a microwave because y'all know that's something different, but the UVC is so small that it's cutting. And so it can get into our cells, into the nucleus, and actually do damage on the DNA for skin cancer. And it does the same for plants as well. But all people will burn and all people will age. Okay, so which one, and mark it down, let's see who can answer first. Which one do you think we're using sunblock really for? What is sunblock targeting? Exactly, Katie, and private. It's UV. Sunblock is actually created to block UVC. B, yes, for burning, that you don't want to get burned, but the most severe is UVC. So, and that's why everyone, even if you have melanin in your skin, that helps protect you from burning, you still need to use sunblock because you want to be protected from UVC rays. Got it? Thumbs up. Good, Evelyn from private. Y'all are funny. Okay, so let's just decompress about all the things that we learned because we're done with that box, right?
Yep.
Okay, so what are some effects of global warming? Let's put them in the group chat. What are some things that are caused because of global warming, this hole in the ozone? Let's lay them out there. What are some things that are causing, that are the effects of global warming? Ice caps melting, multiple rays entering the earth. Yes. Anything else? So Katie, can you publicly say why ice caps melting are an effect of global warming? Good, Keithan, disappearance of the stratosphere is an effect.
Yeah.
Increased skin cancer from the sun. Very good, Kelsey. Who else? We got 30 something people, 25 people on here now. I know my scholars, but I know y'all aren't speaking up too. Don't let me call you out.
Mm-hmm.
So Katie says, because the heat is being trapped on Earth, and that's why the ice glaciers are melting. What are some things that if the ice glaciers melt, why is that even a problem? Good. Angel said methane releases methane is going to be released from the ice caps in private. Good job, Angel. Kelsey said rise in the water level and potential flooding, coastal flooding. Very good.
Yep.
The rays won't continue to bounce off the earth.
Like they're gonna come in.
Oh, okay, yeah. More rays, increased rays. So that is called global warming. And the other thing is, how is climate change different from global warming? Want to be clear about this. I'll put many F's. How is climate change different from global warming? We've heard about climate change so much. We've heard about global warming. Is it the same thing? Is it different? Let's see, where are my scholars at? So climate change happens seasonal and global warming can happen at any time. Global warming is a rise in the temperature. Okay. Good, Brooke. So climate change is the swing of things. Like there's a lot of things that are gonna control climate change, right? The tilt of the earth, weather patterns, where it's located on earth. So sometimes you're gonna see cold when it's not supposed to be cold because there's a shift in the weather pattern caused by global warming. So the earth is heating up generally, like, was it 3 points, three temps per year, something like that. It's heating up really, really, really fast, but that doesn't mean it's just gonna be hot all the time, like people think. It actually is changing the weather patterns and creating cold when it's not supposed to be, and super hot when it's not supposed to be that hot. Like June, July, and August, I think were the hottest of history, the hottest months in all of history. So that means like that's a big problem for us. And that is because of global warming. But also 2 years ago, we had snow in, what was that, March? Was it March?
March or April. Yeah, one of the two.
We had snow really late. And that is also because of global warming, but it's indirect because it's climate change that's causing it and not just global warming. Does that make sense? Put a thumbs down if you still don't really understand it. I think of it as an umbrella where global warming is here, but then underneath it is climate change because it's a result of the bigger picture, which is the global warming. Okay, I see some thumbs up. I don't see any thumbs down. All right, so we can open you guys up to any conversations, any talks. You guys are at home, we are too. And we just wanted to be able to let you see our faces, even though you guys blocked yourselves, we can't even see you.
Right.
We do miss you, and we hope you guys are keeping up with the assignments. If there's any questions, you can ask them now about what has happened throughout the week as far as your assignments. Oh, Josh, you don't have your do-rag on? I miss you guys so much. I really do.
Yes, we'd all rather be in school with you guys.
So yeah, any questions?
Miss Bannerman?
Yes.
Yesterday when you gave us that assignment to do on Remind,
Uh-huh.
what do we have to actually do? Because I got a link.
Yesterday was for you guys just to watch the video. There wasn't anything that you had to submit, but you guys should have already submitted your human activities books. That was Monday. And then on Tuesday, you guys were supposed to, let me check my thing just to make sure. On Tuesday, you guys had your cookie lab that you had to do and submit that. And then Wednesday, you guys should have submitted your questions for your anchor phenomenon. So there's 3 things that you guys should have submitted to the Dropbox.
I did. Oh.
Okay, then you're
Thank
good.
you.
Uh-huh.
And then for me, you guys know, we've been on Flipgrid all week. And that is just kind of how you're gonna be submitting your stuff. Take a picture of your stuff if you want to. You can type it on the screen if you want to. No, Brooke, you can go. Anyone, if you guys need to go, it's fine. We're done with the information. I will post some instruction for you guys for later as far as let me see your notes, because I want to see your pretty pictures. But
Yeah,
if you need to go, because I know other teachers are probably trying to get their Zooms in for the week as well. So are there any more questions? So we'll just do a little, bye, Katie. There's a little sneak peek about next week is you guys are going to be doing some individual research. So just look out for that. I'm not assigning anything this weekend. Are you, Bannerman?
Nope.
Nope.
As long as you've got your first 3 things submitted, then you're good. If not, then you've got some work to do this weekend to get those things submitted.
Bye, Josh. I want to give you a big
Bye.
hug. I miss you so much.
Thanks,
okay.
Stephen.
My students in Remind, those green posts, I'm saying Monday, Tuesday, Wednesday, Thursday, Friday. And you should be checking back with me and saying, okay, I have this left to do. I haven't done that. So you guys are doing a great job at submitting your assignments via Flipgrid, and then your flip books, human activities booklets through Dropbox or on Flipgrid. You could do either one, but just make sure you're keeping up. This is a different learning type of thing, but we don't want you just to be sitting there and not using your mind. So we're not going to try to overwhelm you with work, but we do have work to do. Okay, we are responsible to teach you guys environmental science, and you guys should know some things when you're done. Okay, so don't just sit back and relax. Tell your friends.
Yes, because there's a lot of people missing from the Remind, and I'm just assuming that you guys are checking the blog if you're not in the Remind. But if you know people who are in your class or taking environmental science from either Ms. Ned or I, make sure that they're in our Remind so that they are getting updates, or you share, you know, what they need with them. Be a good friend, pass it along.
Also, if you're missing out on anything, I got a question from a couple students about how, I think you can go to files and Remind. If I've uploaded things, would that show up for them? Okay,
Yes.
because I can't keep posting the same things over and over and over and over. Like, you're gonna have to kind of go through the history of the Remind, and it should be stuck there somewhere, especially if it's a picture or a file. And if you cannot find it there, then I will help you that way. Or you can ask a friend too, because you have people, you guys have contact with each other as well. Ms. Hathorn and Ms. Sanchez, you guys have anything?
Hold on, you're muted, Sanchez.
I tried to unmute her.
Let's see.
Hi, I was just gonna say that it was very good. I took my notes and I'm posting it into my blog too. I hope you don't mind.
No, that's awesome.
Anything you need to say to any of the students? Okay, homework done.
Yay! And the colors, awesome.
Yeah, Kelsey, I see you celebrating. Oh gosh. Okay, I'm gonna stop the record on here.